Okay, so I said I'd give you the solution to this problem, and then after this problem I'm going to do another one that's similar to this, and then one other problem that's similar to a test problem, and then at the very end I'll give you a way to memorize the trig function derivatives that's really easy. Not the inverse ones. Those are annoying no matter how you do it. I don't think there's an easy way, but just the regular ones. So okay, so this problem, this is the one where it's like find the tangent and normal lines at this point for this curve. This one's harder, I think, than what's on your test. So we just got to do the derivative of that thing to get our derivative, which is basically our slope function, and then we can plug that point in to get our slope and write our equation for our tangent line. So derivative of this is going to be 1 plus, that sucks. So, but I think in your book it's square root, so anytime you see a square root and you're going to do the derivative, you just change it to 1/2 power. So derivative of the outside, we got an outside here, and then on the inside we're going to have product rule. So that's why I said that sucks. So we're going to have 1 plus, let's see, we're going to have 1/2 times xy to the negative 1/2. There's the derivative of the outside, times the derivative of the inside, so times the derivative of x times y. So I'm going to come over here, derivative of x times y, well that's the first one, product rule, right? Plus, times the derivative of the second, plus the second one, times the derivative of the first. So there's your derivative of the inside. So that's x dy dx plus y. And this is, remember, this is chain rule, so we did the derivative of the outside right there. It's multiplied by the derivative of the inside. So this whole thing, gotta remember to multiply it. It's x dy dx plus y equals 0. Okay. So now we got to simplify this thing, right? We got to get the dy dx alone. This one's going to be no fun. Here comes the fraction thing, which you guys hate. We have 1 plus. Well, let's just go ahead and subtract 1. Get rid of that. Minus 1. So we got negative 1 over here. Now we'll work on this. Well, we got 1/2 in front. So I'm going to turn this whole thing into a fraction, because I have this negative 1/2 power. So that's like the square root of xy, and that's going to be on bottom. And then this is going to be on top. And that actually worked out all right, because it's just 1 times this. So really it's just x dy dx plus y. So I don't even need the 1. So now to get dy dx by itself, just get rid of that crap on the bottom by multiplying by it. So I'll multiply by 2 root xy. So I got x dy dx plus y equals negative 2 square root xy. Subtract y and then divide by x. So my answer is going to be negative 2 square root of xy minus y all divided by x. There's my derivative function. So if I just plug in my point now, I'll get my slope. I think it was 4, 1. So negative 2, x is 4, y is 1. 4 times 1 is 4. Square root of 4 is 2. 2 times negative 2 is negative 4. So I get negative 5 fourths. So there's my slope. Now I just got to write my point on my equations. This was at 4, 1. So my, what's it called, tangent, and normal. So y minus 1 equals negative 5 fourths, x minus 4, and then obviously y minus 1 equals positive 4 fifths, x minus 4. So that one was tricky, right in here. like I said, the one on your test is easier, so this one is more test-like. 2x to the third plus 4y squared equals 100 at -4, 2. So again, another tangent and normal problem. Go ahead and pause it and try it completely if you'd like. So find the tangent and normal lines. Let's see, do the derivative. Derivative of this would be 6x squared plus 8y, don't forget your dy dx, equals 0. That one was nice because there was no chain rule, product rule crap. Now subtract 6x squared, so I'd have 8y dy dx equals -6x squared. Divide by 8y, so dy dx equals -6x squared over 8y. Of course, you could reduce that down to 3/4, but it doesn't matter because we're going to plug in points right now anyway, and then we'll reduce our slope. So just plug in x and y. So -6 times -4 squared over 8 times 2. -4 squared is 16. 16 times 6 is 96, I think. Hope that's right. 96 over 16. I don't think that works. 6? 6? Yeah, I think that's 6. -6. I'll make sure so I'm not giving you false information. 16 times 6. 96 divided by 16. Oh, does. Of course it's 6. That was stupid. -6. So there's your slope. So now your tangent and normal lines. Easy. Y minus 2 equals -6 times x plus 4. And then normal y minus 2. Flip the slope and change the sign so it becomes 1/6 x plus 4. That's it. Let's see. I'll show you the memorization thing right now. Can't believe I forgot about this. It's just for secant, cosecant, cotangent, and tangent. I was like, I know there's one more. It's not for the inverse ones, and it's not sine and cosine. You just have to remember. But so the way it goes is, let's say you're taking your quiz on derivatives, and you can't remember one of them, and so you want to cheat. So, you say to your neighbor, it's quiet, so you go, psst, to get their attention, you make the psst sound. Well, that sound is that psst sound, psst, yeah. So, stay with me here. Ignore the P, SST. S is secant, so you have secant, and then you write secant, and then you write tangent. Below those three, you write the opposites of them. Opposite of secant is cosecant, cosecant, and cotangent. Okay? Then, you just got to, this is the only weird part, put a negative right here on the bottom middle and put arrows. Okay, so what's it all mean? Well, now if you want the derivative of secant, secant's right here. The derivative, follow the arrow. Derivative of secant is secant times tangent. So derivative of secant is secant tangent. Derivative of cosecant is negative cosecant times cotangent. Pretty sweet, huh? If you want derivative of tangent, it's secant times, you go backwards, secant squared. If you want derivative of cotangent, you go backwards this way, it's negative cosecant squared. So I know those are kind of confusing, so that's an easy way. So you just start with, you put SST, put the opposites, put a negative, and then put your arrows. So it's kind of cool. I don't know if any of you will use it. You've by now probably already got your own method of memorizing. I just thought I'd throw it out there since I just thought of it. So I'm going to do one more problem that's quiz-like. 4 divided by the cosecant squared of x. another good one to pause and try on your own. If you've already unpaused it after like 3 seconds because you have no idea where to start, here's a helpful hint. Remember I told you if you see a trig function squared, rewrite it as cosecant of x squared. That's the whole thing squared. So now you might want to pause it and try it. You might try quotient rule. But if not, even better would be to just rewrite it as 4 and bring that up. Cosecant of x to the negative second power. Now the derivative is really easy to do. So I just made it look better. So now you might want to pause it and try it if you are still stuck. And so now it's a lot more doable. So just going ahead now. Now it's pretty easy actually. It's just chain rule. Derivative of the outside would be negative 8. Cosecant of x on the inside. And then you got to subtract 1 from the power. A lot of people put negative 1, they mess up. But remember, it's already negative, so negative 2 minus 1, negative 3. Times the derivative of the inside. Derivative of cosecant, we'll use my thing up here. It's negative cosecant times cotangent. So negative secant of x times cotangent. Obviously, I didn't put the x's on there. So there's that. So your final, we can do some stuff with this. We've got a negative power with this guy, so let's move him down. So on top we have negative 8, and then negative cosecant of x times the cotangent of x. This is multiplication over cosecant of x to the third. Well, it's all multiplication, so I have negative 8 and a negative here, so that's just going to be positive 8. And then notice it's all I'll rewrite it just so it's not confusing. So it's 8 cosecant of x cotangent of x over cosecant of x to the third. Sometimes I'm putting parentheses around that, sometimes I'm not. It doesn't matter. Well, I got cosecant on top, cosecant on bottom, so I can get rid of one of them. So your final 8 times the cotangent of x over cosecant squared of x. And you can write it like that, or you can leave it in your answer as cosecant of x squared. Those are the same thing. It does not matter. And we might be able to mess with that a little more, but at this point I'm happy with that. Don't even care. So I think that's it. Lots of derivatives on your test tomorrow. There's 8 derivatives. One of the problems, one of these 8 derivatives, and then 2 bonus problems that are just finding derivatives. And any of them could show up. It's not just these. There's inverse cosecant. There's inverse cosine. There's inverse tangent. There's inverse ones. There's ln's. There's e's. So you still need to remember them all. So if you forgot some or you didn't get 100% on your quiz, you better study those a little more because you will need to know those in order to be successful. And that's it. See you tomorrow.